Hello, welcome to Technoveda Solutions. We are going to start a new series on C programming. Even though we have many C programming videos already available, but this is going to be very unique as we are going to discuss a lot of things in detail and in depth. So this will be very useful for those who want to be a very good programmers and build a career in programming concepts and coding. Well, in future sessions, we will be discussing a lot about the coding along with the concepts. To start with, let's understand what exactly a C programming is and what is a compiler. Well, C is the first compiler based language. Before that, whatever the language we used to have, all were based on a interpreter. So C was the first introduced language which is based on the compiler. In the later session, we'll see how exactly a compiler and interpreter are different to each other wherever required. I'll be giving the examples related to that. So C is also a very simple high-level language. It has a simplicity of high-level language. When we say high-level language, that means the keywords what we use are very close to our standard English language. So understanding their meaning would be simple. At the same time, it will also provide us a power of low level language so that we'll be able to do a lot of coding which are very close to hardwares, and we'll be able to control the execution in the hardwares. So this is based on the structure programming method. So let's see how exactly a compilation happens in the C program. Source file is one text file wherein actually the program is written and it is saved with the .c extension. This is fundamentally a text file, so this file can be opened in any text editor and we can see the content of this particular file. And this file will contain one function called main function. That is where the execution actually starts. Whenever compiler wants to execute the program or compile the program, it looks for this main function before generating the exe file. However, without main function, we can generate up to object file, but exe cannot be generated if the file does not contain a main function. To generate a exe file, we have to compile this program containing main function. So to open this file in GCC compiler, we can use vi editor. So vi space filename.c will open the editor window where we can actually type the program. Then the first step in the compilation process is pre-processing. In pre-processing, we have lot of instruction with the prefix of hash symbol, that is hash include, hash define, hash if, hash pragma. Like that we have many instruction prefixed with a hash symbol. All those instructions are classified as a preprocessor instructions. So basically, whenever we want to include a file or define a macro, we use these hash symbol very commonly. But whenever we want to create a header file, sometimes we need to execute a certain part of the code based on the condition. So that time we will be using a conditional execution using preprocessor instruction. We will see all the pre-processing instructions what are used in the coming sessions. So preprocessor is a tool which basically removes all the comments whatever the user has added, because those comments are not required in our execution file. The comments are only for the user understanding. So this preprocessor generates a file name .i, the file name with the extension .i from .c file. So command to generate a preprocessor file is gcc-e filename.c, where e is a switch which is a capital E. The second step is compiling. This is a tool which converts our .c program to .asm or assembly language code. So till now the C program whatever we have, that is platform independent, but assembly language program is hardware specific, whereas C is a hardware independent program. So this C file which is converted to assembly, will have a hardware specific program, and it will provide a segmentation details. What are the different segments used and how those segments are used for to store the different data, that also we'll see in detail in the coming sessions. Basically, this .asm or .s file, that is a assembly language file, is also a text file, so we will still be able to read the content of that. So extension will be either .s or .asm, depending on whether we will be compiling on the Linux or Windows, depending on the compilers. So to generate this, we use a command gcc-s file name .c. So -s is a switch used to generate a assembly language file. Once the assembly language file is generated, then it is given to a next tool called assembler. The assembler converts this .asm file or .s file to an object file with the extension .o. So object file is not readable. We cannot open it any editor, or we cannot read the content of that file. So the file will have extension .o. The command to generate this file is gcc-c file name .c. -c is a switch to generate an object file. Once we have the object file, then next tool will come, that is linking. So the tool linker actually performs the linking of our source code to the library functions which we have invoked, or a user defined functions which we have written in the code. All that code which should be linked to our source code. So that linking is done by linker. So that means before linking any library functions, our source code should be converted to .obj. That is because all library functions are in the form of object file. So after linking, this linker converts the file to executable, that is .exe or .out or .hex, depending on where we want to execute. In Windows we use .exe, in Linux we use .out, and if you want to execute this on the target hardware, then we'll be using .hex files. So command is gcc-o file name .c. That will generate an object file. Then finally, now we have an executable, so we have to load that to a primary memory before execution. So that is done by the tool called as loader, which actually loads the program to a primary memory for the execution. Or if we want to execute it on the target hardware, then flash programmer is used. Most of the IDE will come with the flash programmer inbuilt, or we can use a third-party flash programmers also to burn the program into a target hardware and execute there. So based on where we want to execute, there are two types of compilations. So this is a consolidated compilation process, how exactly the things are happening. So we started with the source code, then preprocessor, then we generate an intermediate for .i, then comes the compiler which converts the .c to .asm, then .asm is given to assembler which will generate a .object file, then that object file is given to linker, then the library functions and other object files are linked and the executable is generated. Then we use a loader or a flash burner to load it to the memory for the execution. Based on whether we want to execute it on the native hardware or the target hardware, we have two types of compiler, that is straight compiler or cross compiler. In case of straight compiler, the execution happens in the same machine where the program is compiled, whereas in case of cross compilers, the execution happens in the target hardware and compilation happens in the native hardware. That means if I am using my laptop to write the code and compile the code, finally I generate an executable for some external target hardware. I want to execute it on another board. Then I have to generate an executable for that board. That means we are generating an executable for some target hardware. That is called cross compilation. Okay. So more concepts related to a programming model we will see in the coming sessions. Thank you. Like, share and subscribe the video. And if you have any questions, you can always contact at technoveda17@gmail.com, or you can comment to the videos. Thank you.